Good morning. Rohini College of Engineering and Technology, aggregated with A plus grade by NAG, Department of Civil Engineering, CE 3402, Strength of Materials, Regulation 2021, A. Anand, Assistant Professor, Department of Civil Engineering. So, here you're going to see the topic Conjugated Beam Method. Conjugated beam is an imaginary beam of length equal to that of the original beam, but for which the load diagram is the M divided by EI diagram. First point is the slope at any section of the given beam is equal to the shear force at the corresponding section of the conjugate beam. And second point is the deflection at any section for the given beam is equal to bending moment at the corresponding section of the conjugate beam. Hence, before applying the conjugate beam method, conjugate beam is constructed to the load on the conjugated beam at any point is equal to the bending moment at the point divided by EI. Hence, the loading on the conjugated beam is known. Then the shear force at any point of the conjugated beam given the slope at the corresponding point of actual beam and the bending moment at any point on the conjugate beam gives the deflection at the corresponding point of the actual beam. Here, slope and deflection of a simply supported beam with a point load at center. So for this, there is a formula RA is equal to RB is equal to total load divided by 2. Bending moment center C is equal to RA into L by 2 is equal to W by 2 into L by 2 is equal to WL by 4. The shape of loading on the conjugate beam will be same as for bending moment diagram is equal to W into L. The ordinate of loading on conjugate beam will be equal to, so M divided by EI is equal to WL divided by 4EI. So this is the simply supported beam. We are having the bending moment and shear force diagrams. RA and RB, reaction at A and reaction at B, and total load on the conjugated beam is equal to WL square by 8EI. And next, slope and deflection for a simply supported beam with a fully distributed, uniformly distributed load. So, a simply supported beam AB of length L carries a UDL at its center. Since the beam is symmetrical load, RA is equal to RB is equal to total load by 2. We are getting the bending moment at center is WL cube by WL square by 8. And here there is a shape of the loading on the conjugate beam will be same as bending moment diagram, that is WL square. So this is the diagram. You are having the moment, that is WL cube divided by 12 EI, reaction at each support for the conjugate beam. So you have to see the problem. A beam ABCD is simply supported at its ends A and D over a span of 30 cm. It is made up of 3 positions AB, BC and CD, each 10 meters in length. The moments of inertia of the section of these positions are I, 3I, 2I respectively, where I is equal to 2x 10 power 10 mm per 4. The beam carries a point load of 150 kN at B and a point load of 300 kN at C. Neglecting the weight of the beam, calculate the slope and deflections at A, B, C and D. Take E is equal to 200 kN per mm square. So solutions in that, first you want to find the reactions RA, RD, that is RD is equal to 250 kN and RA is equal to 200 kN. So this is the diagram. You are having the bending moment diagram by using the conjugate beam. So here the bending moment calculators will be there. Bending moment A and D is equal to 0, B is equal to 2000 kN meter, C is equal to 2500 kN meter. The slope at the given beam, getting the value 0.0031 radians, slope at B 0.007, slope at C 0.001 157 radian, slope at D 0.00272 radian. And deflection at A, the bending moment for the conjugate beam is equal to 0. So in this deflection at B, bending moment for a conjugate beam we are getting the value 23.84 mm. Deflection at C, we are getting the value 21.99 mm. Deflection at D is equal to 0. Thank you.